Okay, there's some questions in MyStatLab that ask you to compute areas given some set of z-values. So let's try a couple of those. Let's say that it asks if you want to find an area where z is greater than 1, just to take a simple case. So first let's just draw a bell curve with x. Actually, the axis here is z and x. We're looking at the standard normal distribution, which has a mean of 0 and a standard deviation of 1. That's what a z-value is. So we here have the mean is equal to 0, the standard deviation is equal to 1, and z equal 1 is right here. So if z is equal to 1, we'll go over to our z table, and if you look over here on the left-hand side where z is equal to 1, you will see next to that the area 3413, which we'll note is about half of 6/8, which is what we had in the empirical rule before. So that means that from the mean to this point where z is equal to 1 has a probability or an area of 3413. Above there would be 0.5 minus 3413 because we know this is a perfectly symmetric distribution. So 0.5 or now. So we're interested into this, in this area, greater than 1. That's what it said. And we know from 0 all the way up, or for the mean all the way up is 0.5, but that from here to here is 0.3413. So the area here is 5 minus 3413 over 0.1587. Okay, so let's look at another one here. And let's say now that we want to go from z is equal to minus 0.82 to positive 1.47. So I'll draw my curve here. In this case, it's the same scale there, x and z. And so, here's the center, 0. So z equal minus 1.82 means that we have a point that is 0.82, not quite one standard deviation below the mean. Remember, everything has to be with respect to the mean. So we can find that area. So we want to go from minus 0.82 standard deviations below the mean to an area, to a spot that's z equal 1.42 or 1.42 above the mean. So let's call this area A, and we'll call this area B. So for area A, we'll just go to the z table and look over at 0.82. So I'm over here on the left-hand side of the screen, just go from z down to 0.8 and then over to 0.2, and you should see 2939 over here. So area A is equal to, what did I say, 2939. And then area B, which is 1.42 standard deviations above the mean. So I'll go to 1.4, I'm sorry, should have been 1.47. 1.47. Get myself lined up here and stay straight on the screen. Looks like 4292. 0.4292. That's area B. And so we'll just add those up. And if I did my adding correct, that would be 7231. So let's try one more here. Let's say that we want to go from z equals minus 1.62 to minus 0.58. Just making some numbers up there. Now both of those are below the mean. So this is z, or in x in this case. Mu is equal to 0. The reason the mu is 0 is that the center of the thing is no standard deviation to the mean. It is the mean. So we'll go down to 1.62 minus 1.62, we're below, to minus 0.58. I'm looking for this area, all of that. I'm not going to shade it all in there, but maybe you can see what I mean. And so recalling that everything has to be from the mean, I can take this area, which I will call area A, and it's 1.62 standard deviations below the mean. So if you go over to your table and go down to 1.62, I'll make that area A. Z is equal to 1.62, so that's 4474 over on the Z table. If I copied that down right, 4474, okay. And so area B would just be this part. And so area B, where we have Z is minus 0.58, we'll just go over and find 0.58. All the minus means is we're below the mean. And if you're 0.58 below the mean, you will have included an area of about 0.2190. And so so if my math's okay, if it's not, you can change that answer. I think it is, though. And that's how to work the ones where they give you a Z value.